Latent image formation. In our previous videos, we saw how X-rays from the position indicating device interact with patient tissues, after which they fall on the X-ray film. What happens next is latent image formation, which is what this video is about. The word latent means hidden or concealed. A latent image is formed on the X-ray film when the X-ray photons exit an object and fall on the film. This is not visible to the naked eye, hence the name. The image becomes visible only after processing the X-ray film, which can be compared to how photographs were processed before digital cameras came into being. Now, in the previous video, we learned that an X-ray film consists of multiple silver halide crystals, each consisting of silver bromide arranged in a three-dimensional lattice configuration. These silver halide crystals contain a few positively charged free silver ions, or interstitial silver ions, between the lattice atoms. Trace amounts of sulfur compounds and iodide present in the crystals create multiple sites sensitive to radiation called sensitivity sites. When a beam of photon exits an object and exposes an X-ray film, it chemically changes the silver halide crystals to finally constitute the latent image. Let us see how this happens. After exiting from the object, when the photon reaches the film, it interacts with the negatively charged bromide ion. An electron is released, thereby converting bromide ions to bromine atoms. These recoil electrons have sufficient kinetic energy to move about in the crystal and reach the sensitivity site, imparting a negative charge to it. The free-lying positively charged interstitial silver ions are then attracted to these negatively charged sensitivity sites and reduced to form neutral metallic silver atoms. Now, these sites are called latent image sites. The overall distribution of these sites in the film constitutes the latent image. Pop quiz. To summarize, the latent image is formed in three steps. X-ray photon interacts with the bromide ion from which an electron is released. This electron moves and gets trapped in a sensitivity site, imparting a negative charge to it. Positive interstitial silver ions get attracted to the sensitivity site and form neutral metallic silver atoms. These are latent image sites, and multiple such sites form the latent image. As a dentist, how will the latent image be useful to me if I cannot see it? This means I will have to convert it to a visible image. This is achieved by a procedure done in a dark room called film processing. My first step is to dip the film into a solution called the developer for a specific amount of time at a specific temperature. What do you think happens here? A chemical reaction called reduction takes place. How? The developer contains a reducing agent called metolphenidone that gets catalyzed by the neutral silver atoms at the latent image sites, giving out an electron when in contact with the film. The silver atoms act as a bridge by which these electrons reach the silver ions in the exposed crystal and convert them to solid grains of metallic silver. Eventually, as this happens, all the exposed crystals develop. That is, they are reduced to black metallic silver. In other words, this creates dark or black or radiolucent areas on a dental radiograph. At the same time, the unexposed silver halide crystals remain unaffected by the developer. To see the radio-opaque structures, I rinse the film and put it into a solution called the fixer. The fixing solution has a clearing agent, which could be ammonium thiosulfate or sodium thiosulfate. This chemical reacts with all the unexposed or undeveloped silver halide crystals or the crystals that contain no latent sites, converting them into a soluble substance that can be subsequently washed from the film. This creates white or clear or radio-opaque areas in the radiograph. In short, the developer solution enables us to view the radiolucent structures, and the fixer helps us to visualize the radio-opaque structures. In this video, we have covered film processing superficially. Keeping these concepts in mind, we will learn film processing in depth in the next video. We hope you had fun learning with us.